Welcome to the House of Maths. Today we're going to be finding out about finding the angle in a right angle triangle. Now to do this we're going to be using SOHCAHTOA. Now I've done a video on this already, so I'll put a link below for you to check that one out. So let's get on with it for today. So we're using SOHCAHTOA, as I say, so we need a right angle triangle. Is our right angle triangle, and we are going to be trying to find this angle over here, and we are going to be given some information. Okay, we've been given those two sides, so we've got to use that to try and find that angle. So let's see, in relation to this angle we've got an adjacent next to the angle, and we've got the long side. Remember, that's opposite the right angle, so that's the hypotenuse. So opposite the angle we're trying to find, this side here is the opposite. Okay, so the best way to use SOHCAHTOA is to look at what you don't need. So we don't need to find out what the opposite is. So on our SOHCAHTOA we've got an O in that bit and we've got O in that bit, so we don't need those bits. So we're going to use the K bit. So I'm going to write that down. We're going to use, sorry, I said K, not sine. We're going to use cos theta equals adjacent over hypotenuse. Always a good idea to write your formula down first. So let's put in the information that we've got on our triangle. So we've got cos theta, which is what we're trying to find, and that equals the adjacent over the hypotenuse. Well, the adjacent is 7, the hypotenuse is 10, so that's 7 over 10. And we can simplify that quite quickly. We can say cos theta equals 0.7. So that's basically giving us the ratio of those two sides. So that's the cos theta is the ratio of these two sides. So what we need to do now is convert this into an angle, and we can do that by, first of all, we want to isolate the theta. We want to find out, or we want to get theta on its own. So to do that, what in effect we do is we multiply both sides by cos to the minus 1. Okay, to both sides. So that in effect, on this side, cos times cos to the minus 1, they cancel out, and we're just left with theta. And on the other side, we're going to get cos to the minus 1, 0.7. So what you'll do to convert this into an angle, on your calculator, you will press the second function and then cosine and put in 0.7. And if you do that, you will get the angle. So right, now that I've found my calculator, we can do this sum. Okay, so as I say, you want second function on your calculator, then you want to press cosine. So I've done that, and I've put in 0.7, and that gives me an answer of 45.5729, and so on. So usually we're going to give this to a certain degree of accuracy. Let's just say 1 decimal place in this case. So I'm going to put 45.6. Okay, so that's that question done. Let's have a look at another one. Okay, so we're going to look at a triangle orientated slightly differently this time, because they can come at you in any way. So here's our triangle here, right angle up here. We're going to be trying to find this angle here, and we are given that side and that side. So we're going to try and find this angle. So let's have a look what we've got on the triangle so far. In relation to this angle, we've got this here, this side, which is the adjacent, and then over here, opposite the angle, we've got the opposite. So this side is the hypotenuse. Now we're not interested in that side. So that one's got an H in it, we don't want that. That one's got an H in it, we don't want that. So the one we're going to be using is the TOA. So let's write the formula down. So we've got tan theta equals opposite over adjacent. Now let's put the information we've got into this. So we've got tan theta equals opposite over adjacent. So that's 3/8. Now in order to solve this, we're going to have to multiply both sides by tan to the -1. So by doing that, we'll isolate the theta, and that will give us tan to the -1, 3/8. Now we're going to reach for our calculator, which I've got handy this time, and we are going to do shift or second function tan and 3 divided by 8, which gives us 20.556. Okay, 20.556. And if, like before, we're going to work to 1 decimal place as our degree of accuracy, that's going to give us 20.6 as our answer for that question. Okay, now let's look at a slightly harder question. Okay, so here we are with our slightly harder example. Now, what we've got to do is we've got to try and find this angle over here, theta. And if you look at the triangle at the top, if you look at triangle ABD, we've got the angle that we're looking for, theta, over here. And the only other piece of information we've got in the triangle is this side here, AB, which is 6. So that's not enough information in that triangle to work out that angle. So what we're going to have to do is use the other triangle. Notice we've got attached to the bottom of it, we've got another triangle, BCD, which is also a right angle triangle. So we're going to have to try and use the information in this. And notice we've got an angle and we've got one of the sides. So that's useful. We can work out the other sides in the triangle by using SOHCAHTOA. So what I'm going to try and do is I'm going to try and find side BD, because it's also in triangle ABD. So if we can get that side, we'll have 2 of the sides in triangle ABD, and then we can use that to work out that angle. So let's do that first. So remember, we're using our SOHCAHTOA to work these angles and sides out. So we want to find BD. We've got an angle here and a side here. Well, let's have a look what they are. So here's the right angle. Opposite the right angle is the hypotenuse. So that line there is the hypotenuse. We have an angle here, and opposite that angle, call that the opposite, we've got this side which is 8 in length. Next to the angle here is the adjacent. Now notice on this triangle we don't need the adjacent. We haven't got it, and it's not necessary to find it. So we don't need A. So there's an A in that one and an A in that one. So we don't need those. So we're going to use the soft bit to find the hypotenuse of triangle BCD. So let's write down our formula. Sine theta equals opposite over hypotenuse. And now let's put into that formula the bits that we've got. So we've got sine theta, we've got sine 75 equals opposite, which is 8, over the hypotenuse, which is what we're after. So I'll call the hypotenuse BD. Okay, so now we've got to find what BD is. Now we've got to be careful when we rearrange this. Now, in order to help with that, notice the way I've written this, with the O at the top and the H below it. So we've kind of got this sort of setup. So it's telling you that the sine is the opposite over the hypotenuse, which is what we've got here. But if you want to rearrange it, if you want to find the hypotenuse, which is what we're looking for in this example, the hypotenuse is the opposite over the sine. So when we rearrange this, we want BD equals the opposite over the sine. So that's 8 over sine 75. And then we can use our calculator to do that. So I'm going to grab my calculator and I'm going to do 8 divided by sine 75. And that gives me 8.28. And quite a few decimal places after it. Now, when you've got that in your calculator, leave it there. Don't delete it. Don't try to round it up because you'll get an error later on. This is what I would call an interim calculation. So we need to keep the full number in there. But I'll just write it up here for the time being. 8.2822 and so on. Okay, so we've got that side. So now we can look at triangle ABD and try and work out the angle over here, which is what we're trying to do. So let's have a look what we've got in relation to this one. So we've got an angle here, we've got an adjacent, and we've got an opposite. So this is the hypotenuse, and we don't want the hypotenuse. So up here with our SOHCAHTOA, we don't want anything with H in. So that's got H, so's that. So in order to find this angle, we're going to use the TOA bit. So again, write the formula down. Tan theta equals opposite over adjacent. So put the numbers in now. Tan theta equals opposite over adjacent. And then we can do this in our calculator. So I've still kept that number in, I've not deleted it. So all I'm going to do on my calculator now is I'm going to put in 6 divided by, so I'm going to do 6 divided by, and I'm going to put answer in. In other words, that will replace, it will put this bit into the denominator of this sum. So 6 divided by answer, and that's going to give me 0.72 and some other digits. And then I'm going to convert that into an angle. So theta is going to be tan to the minus 1 of this number, 0.72. Okay, so I've picked my calculator up. I've not deleted the number that's in there, I've just left it there. I'm just going to do shift tan and shift answer just to put that number straight in there without any rounding, and that's going to give me 35.92. So 35.92, and there are some other digits, 1, 2, 3, and on it goes. And if I want to have the same degree of accuracy as before, 1 decimal place, that's going to give me 35.9. Okay, and that is our answer. So just to be clear on a couple of things here that are useful, make sure you use SOHCAHTOA, write it the way I've done, so that when it comes to rearranging the formula to work out, in this case, the hypotenuse, you don't make any mistakes. And the other main thing you need to make sure you do with this, if you were doing interim calculations, which we were doing here, on the way to finding this angle, don't round up at that point, only round up right at the end. Okay, I hope you enjoyed that. If you did, remember to hit the like button and subscribe, and there'll be more content coming soon.